My name is Ranieri. I'm the session's chair for this second talk on education at JupyterCon 2020. It's my pleasure to welcome Suraj and Christopher, who will give us an overview of Otter-Grader to grading Jupyter assignments. Without further ado, you have the stage. Thank you.
Sounds good. Thank you. Welcome, everyone, and thanks for coming out to hear about Otter-Grader. First, some brief introductions. So my name is Suraj, and I am a lecturer in the Haligiolu Data Science Institute at UC San Diego, where I teach undergraduate courses, and I will primarily be speaking about Otter from the perspective of an instructor who uses Otter. But the person who built Otter is not me, that's Christopher.
Hello, everyone. Thank you for being here. My name is Christopher Pyles. I am the lead developer of Otter, and I guess currently its sole maintainer. Currently, I'm a software engineer at Google, but before that, I went to UC Berkeley, where I majored in computer science and built Otter as a student with a team of other student developers. So without further ado, I'd like to start off by talking a little bit about auto-grading and what it is, and how it works. Basically, auto-grading is an automatic method that we can use to grade students' code so that we don't need to have graders reading through all the code and trying to determine, having fun, what would Python print exercises. Instead, we can use unit testing-like things to assign grades based on how it works against some public test cases or private test cases. And basically, all it does is it re-executes the student's code in some kind of grading environment and runs a bunch of unit tests against the global environment resulting from that execution. And the reason for this is scale. Auto-grading takes you from the ability to manually grade, 20 to 30 to however many graders you have submissions for an assignment to, scaling quite large. Some of the courses we have at Berkeley are over 2,000 students that are using Otter-Grader to grade assignments at quite large scale. So Otter-Grader itself is an autograder, and it's basically a lightweight, modular, open source autograder designed to grade programming assignments at any scale. It is a successor to another autograder called OKPy that was also developed at UC Berkeley. This one was originally developed in mind with instructors who don't have access to large-scale compute resources in mind. Its original inception, or the idea behind its inception was that you could collect a bunch of submissions for programming assignments, download them all onto your laptop, and then run all of them in Docker containers, and then just get like a CSV of grades. That has since expanded quite a bit into the way it's used now at UC Berkeley in conjunction with an LMS called Gradescope. But that was the original idea behind it. So Otter itself works with both Python and R assignments. It was designed for data science Jupyter Notebook assignments, but it is compatible with other formats like scripts and R Markdown files. The package itself includes tooling for developing and distributing assignments, and you can run, as I said, assignments locally or with third-party services like Gradescope. And the core abstraction, again, is that you, as the instructor, provide compute to run assignments, and Otter will take care of all of the rest. So to set up Otter, it's actually very simple. All you need to do is pip install the Python package. And then if you're going to be grading locally in Docker containers, there's also a Docker image that you need to download as well. So in today's talk, we have kind of three main parts. We'll do a short demo of the assignment authoring, release, and collection process. We'll discuss various use cases and extensions, and then finally we'll discuss some shortcomings of Otter, areas we hope to improve, and future plans for development. So to begin, student-facing notebooks kind of look like this once they come out of Otter's assignment distribution tool. The kinds of questions that work best for Otter are where you provide some exposition and then skeleton code where students are going to be filling in the blanks. So for example, we have this a cubed plus b squared function, and if I just run this right now, obviously I'm just returning ellipsis, which is going to throw an error because you can't add ellipses together. And then inside the notebook the student sees, we have these cells that call this grader.check function. And what this is doing is it's taking the a cubed plus b squared function the student defined, running it against some test cases, and then if those test cases pass, it's going to say it passed. But here in this example, obviously, this throws a type error because we can't add ellipses. So what I do if I want to, say, actually fill in the function, and then we will see that I have passed the test cases because I've actually done it. In this example, though, this is just checking at the moment some public test cases. So there's only one public test case. So if I say, let's just return the value expected by that public test, I'm still going to be passing even though I have not correctly implemented the function. And so this is kind of the level of granularity you can get where you have public tests that allow students to check, the reasonableness of their answers. But then you can have hidden tests that are run only by the autograder when it's determining the final grade and are obfuscated from the students that actually check correctness. So to get a question like this, you may have some snippet in a source notebook, some instructor-facing source code that looks like this, where we've defined a question with a name. We have our exposition here in Markdown, the solution to the example or the question, and then some test cases down here. And then all you would do is have these run, save this notebook, run it through Otter, and you would end up with that student-facing version. Okay, so this is one workflow. This is kind of the main workflow that we see used at UC Berkeley and Suraj uses at UC San Diego, where you start by creating a source notebook, which I will show an example of one in a second. And by the way, if you'd like to follow along with this demo, you can open up this URL in your browser. It is a Jupyter Lite instance that I'll be showing in this demo. Then you would run Otter assign, which is the tool I've been talking about. You then distribute the student-facing notebooks, collect all of the submissions, and then grade them on whatever your grading platform is. So the source notebook itself consists of all the skeleton code with the solutions, as I've just shown, all of your test cases, some question-level metadata, and assignment-level metadata. So let me show you an example of what that looks like. So this is an abridged version of a project that we wrote for another course at Berkeley called Data 88 that also uses Otter. As you can see here at the top, we've got a little bit of assignment config. Like, we say, oh, we require this file to be distributed with the notebook because students will need it. Some other configurations. And then the rest of this is just exposition for the assignment, some imports, etc. And then finally we get into the first question, and we've demarcated that I've begun the question with a notebook raw cell. Then we have the question exposition, the solution, and then these test cases. As an aside, this is a different test case format from the one that was in the slides, but it does work the same under the hood. And then, again, end the question, some more exposition, we've got another question. And this is basically what the notebook looks like. You've just got all of your exposition, you demarcate the questions, the solutions, and the tests, and then for some cases where you want to have students write out long-form answers that you want to grade manually, Otter supports that as well. You just note that the question itself is manually graded in the metadata, and then you can provide markdown solutions and do whatever you need to do. So, with this notebook, this specially formatted notebook that you have, what you'll then do is run Otter assign, which is the tool that takes in the source notebook and creates the Otter-Grader version of the notebook. This is a notebook that has all the solutions in it, and then the tests for this directory have public and hidden tests included. And so this is what's used to generate this zip file that we're going to use to configure the Otter-Grader, which I'll talk about in a second. And then you have a student directory, which contains the student-facing notebook, where we have all those prompts instead of solutions, and only public tests. So if we go back out into the demo, you can see here in this out directory, we have an Otter-Grader directory. In the notebook, if we open it, we've got all the solutions included, but you'll note that we have this cell to initialize Otter, and all of our tests have just been replaced with this one cell that calls grader.check. And if we go into an example test, you'll see that I have the hidden test and the public tests in this example. But if we go out into the student directory here, again, we've got all the test cells gone. We've got only the initialization of Otter, and all of our solutions have been replaced with those ellipsis prompts And if we look at a test, that same test, the hidden test is gone. So that is what auto-assign does. And then, so what you can do then is you have that student directory. All you can do, you just take that whole directory, put it in your GitHub repo, however you're distributing it to students, and you ship that. And it's all there. Students can go in. They know exactly where their code needs to go. They have the public test cases. And then Otter takes care of, for example, generating the submission zip file. But for distributing, I'm going to hand it back over to Suraj, who's going to talk about his workflow.
Thanks, Chris. So as Chris mentioned, once you run Otter-Assign, you have the student folder that somehow you need to distribute to your students. And there are a variety of choices you could make. Like one thing you could do is just submit or upload that zip file or to make a zip of the student directory and put it on Canvas or whatever learning management system you're using. One thing you could do if you want your students to get familiar with Git is to I think I have to stand a little closer here. If you want them to get familiarized with Git is to have them clone a course GitHub repository. But one thing we often do in our introductory courses is use nbgitpuller. And so here's an example screenshot taken from the course I'm teaching this quarter, which I should be doing lecture for right now, but I'm here instead. And you can see there's a link that just says data frames and data visualization. And when students click that link, really, this is the link that they're opening, and you can see, if you're not familiar with nbgitpuller, what this is saying is open our UC San Diego Data Hub, another term for Jupyter Hub, open our course GitHub repository, DSC courses, DSC 10, 2023 SP, and then open this homework2 file. And this homework/homework02 folder, that's just a renamed version of a student folder that was the output of Otter-Assign. So we're just taking that literally and giving it to students, and as Chris showed, it's all good to go. Okay, then how do we get things set up so that students can actually submit it once they have access to this student folder? Well, first, we take the Otter-Grader configuration zip file that we get from the Otter-Grader folder from Otter-Assign, and we one thing we can do, and one thing we often do in our workflows, is put this on our learning management system that is configured with auto-grading capabilities, such as Gradescope. So we'll talk briefly about how you can do this without Gradescope in just a minute, but often what we do in these courses is just take that zip file and upload it as the autograder on Gradescope, and that's really all you have to do. You don't have to tweak with any configurations there. It's all handled for you in the zip file that Otter-Assign gives you. So it's really nice there. Once you've done that, you need to collect your student submissions. And so in my workflow, where I use Gradescope, what students do is they just submit their finished notebook files directly to Gradescope. And when they submit, all they will see is the results of their code on the public test cases. And the public test cases are the ones they already had access to in their notebook. Right? So really what they're seeing is just a validation that what they did in their notebook while they were working on Jupyter Hub or locally matches sort of the public tests in our grading system, because the public tests will factor into their grade. However, when they submit, right when they submit, the hidden tests are also run on their code, but they can't see the results of those hidden tests until we decide to release grades. Now, one model could be to release grades right away, or just have it so that hidden tests are always, your score on hidden tests is always shown. And so I've seen instructors do that where in order to see your results on hidden tests, you have to go through the hassle of submitting. And some instructors, and this is typically what we do, we don't show the results on hidden tests until after the deadline, so students can't just repeatedly resubmit and game the system until they've essentially made the hidden test public test at that point, right? And you can also manually grade questions kind of like you can in nbgrader. So let me show you some screenshots here. So here, I made a burner account on my course Gradescope, and I just submitted an assignment. And in this case, you can see that this submission passed all of the public test cases. Okay, and so this is the view of a student, and you can see it says all test cases passed. And from the student's perspective, all this is confirming to them is that they passed all the public cases, which they already knew when working on the assignment. But when this exact same student submitted, here's what I would see on the instructor side. So sure, it would show me that they passed all of the public test cases, but it would show me that they failed several of the hidden test cases. And it would show me, the instructor, exactly which hidden test cases they failed. And so when I release grades to students, this is exactly what they would get to see as well. It would show them their score on every single question, both public and hidden, and it would show them the specific test cases that they failed. Okay? And then here's the UI on Gradescope at least, when you want to manually grade submissions. So for instance, auto-grading plots that result from like Matplotlib or Plotly, that can be a little finicky, and so we often have humans grade students' work. What a concept. And this is what that looks like on Gradescope. Okay, so now you may be saying, hey, well, I don't have an institutional license to Gradescope, or I want to use something else. What do I do instead? And as Chris mentioned at the beginning, the conception of Otter is that it's meant to be platform agnostic. So you don't need to have access to Gradescope to use it. Instead, what you could do is just ask your students to submit their completed notebooks to whatever learning management system you're using, Canvas. You could even just tell them to send you links to Google Drive files, whatever. And then once you get all of your student submissions downloaded on your computer, you can just run that Otter-Grader configuration zip file locally using the Otter-Grade command and the provided Otter Docker image. So you can do all of this locally on your machine without having to have access to platforms like Gradescope. And what you get back when you run Otter-Assign, or sorry, not Otter-Assign, but Otter-Grade, is a CSV of assignment scores for each student. So like, what you see here, you'd have one column for each of these and one row for each student, and then you can upload that into whatever learning management system you want to use. So this is still useful even if you don't know or have access to Gradescope. Okay, so now that we kind of get what Otter is all about and how you would use it, who actually uses it? So as Chris mentioned, it was kind of developed at UC Berkeley with these large data science courses in mind. And so some of the largest courses on campus are called Data 8 and Data 100, and they have often over 1,000 students per semester. And of course, we can't manually grade every single thing they do, and so Otter is quite powerful there. Though Otter is not restricted to just grading Python assignments, so there are courses in political science and public health that use both our notebooks and R Markdown. They're a bit smaller, but they still use Otter, and we've linked an example R Markdown file from a public health course, if you want to take a look at that. Now, most of these courses use a campus-hosted data hub server, though, again, there's nothing about Otter that requires that you do that. You could have students work locally. Data 8X is a massively open online course version of Data 8 that runs on edX that also uses Otter. And the folks at Berkeley have also put together a sort of cloud-based grading system that does what Otter does, but doesn't require you to have access to Gradescope. And so this is for schools that are adopting Berkeley's curriculum, but don't have institutional licenses to this other software. Okay? So at UC San Diego, which is where I am now, our intro course, DSC 10, works very similarly to Berkeley's Data 8. So we use our campus-hosted data hub server, and students use nbgit puller. Though the course I want to talk to you a bit more about now is a second-year course where we want students to get familiarity with pulling and pushing to Git. Well, really, in this course, just pulling. And also, the workflow is slightly different in that students actually write their code and submit their code not in notebooks, but in standalone Python scripts, even though the assignment descriptions are distributed in the form of a notebook. So I'll show you a little bit more about that as well. But several other institutions also use Otter. I was in some talks yesterday of schools internationally that are already using Otter, and we're working with high schools and community colleges that are adopting it as well. Okay, so the course I wanted to tell you a little bit more about, it's called DSC 80 at UC San Diego. There, the philosophy taught is that notebooks are meant for experimentation and when you're like prototyping your code, but when you're building a library of code, that should all exist in separate .py files that you can import into your notebooks for more experimentation. And so in that course, each assignment consists of both a notebook, which contains the descriptions of the problems and imports of the data sets, as well as a standalone .py file, which when distributed to students just has stubs of functions, but students only actually submit the .py file. So they aren't allowed to rely on anything in the notebook when they submit, okay? And so by default, Otter takes a notebook in and gives you a notebook out, but for the purposes of this course, we built an extension around Otter that calls Otter, but then extracts all of the functions that we want students to implement and put that in a separate .py file, and that all uses nbconvert as well. So let me show you a little bit about how that works. So here's a screenshot from an assignment in this course. You can see that it says, complete the implementation of the function extract personal. It reads some messy user data. And you can see here, extract personal isn't defined in this notebook. Right? So we import the relevant data, and then we test that students have implemented the function correctly. Again, you can do the same public test in the notebook, hidden test on Gradescope thing. But the actual function extract personal is not here. Instead, it's in a separately distributed Python file. And so students will complete this here, and then using a cell level magic, I believe, you can have it so that this file is automatically reloaded in the notebook every 2 seconds or something like that. And so this file is imported here, and so students can still experiment with the code in their .py file, but ultimately all they submit is that .py file and not the notebook. Okay, and so the point I wanted to make here is that while this behavior of separating a notebook into a notebook in a .py file is not native to Otter, the assignment authoring process in this course was significantly more complicated before Otter came around. Essentially, I got to UCSD, I had used Otter at Berkeley before, and then I was scheduled to teach this course, and then every assignment was made up of like 20 different files, and I'm like, I don't have the patience to work with this. I'd rather just use Otter, which I know is easy to use, and then just build a wrapper around that, and now it's much easier to develop assignments in this course. So it's just like one of the possible things you could do with Otter. And so I'll pass it back to Chris to discuss some of the shortcomings and future plans with Otter.
Okay. So one of the things that you experience with Otter, and indeed I think this is true of all autograders, is that writing test cases for autograding is both an art and a science. There are a lot of things, a lot of stumbling blocks, and Otter doesn't necessarily have the facility to alleviate all of these issues. So one of these is randomness. Otter has some capabilities that help you work with randomness better. There are some things you can do around seeding randomness between, like whenever a student is going to use randomness in their assignments to make sure that you always get a deterministic answer. The visibility of public tests. So there's, like, for example, if you want to have public tests distributed with a notebook, but you don't want students to be able to like go and read the public test as I did earlier in the example and say, oh, this is looking for the number 129, why don't I just return that? You can do things like hashing. You can also have success and failure messages that are shown to students along with your test cases. But this is still an issue. And there's also some issues around the way that Otter does tests because it's using internally doc tests around the fact that you're comparing the string representations of objects and not their actual values, and things like that. Other things to think about, all autograders tend to encourage guess and check behavior, and Otter doesn't really do anything about that. We do have some issues integrating with other notebook front ends, things like Google Colab and Jupyter Lite. There are a couple feature gaps when running on those environments. These are things that we are working on. There are actively issues on our GitHub repo right now about increasing our compatibility with these front ends. It is on our to-do list. We don't support question randomization, so you can't, for example, write unique exams for each student using Otter Assign. You're going to get one notebook out, and it's going to be the same for every student. And there are some more advanced Jupyter features like cell and line magic that are currently unsupported, but I'm happy to say that is being fixed in version 5, which I hope will be released this summer. We will be supporting these kinds of more advanced features as we're migrating to executing notebooks using nbconfig's execute preprocessor. Future plans. These are kind of broad goals that we have for Otter at the moment. We'd like to expand our ability to integrate with learning management systems beyond Gradescope. Our kind of tethering to Gradescope at the moment is an artifact of the fact that this was developed at Berkeley, where we do use Gradescope quite heavily, but we'd like to expand the range of LMSs that we integrate with. We'd like to support common patterns for grading image creation, like repo to Docker files. And we'd also like to start building a community of Otter users. We kind of already done that. We have a Slack, by the way. If you find your way to the Otter GitHub repo, there's a link to join the Otter Slack there, so please do join. But we'd like to expand this community even further and try and build out like a system of plugins. And so there are a lot of topics we didn't get to cover in this talk. Plugins is one of those. There are ways of like altering Otter's behavior. Otter has a few built-in plugins. That's one of those topics. There's a bunch of them, like working with R assignments, different test formats, seeding, all these different things. So if you're interested in any of these topics, please do look up Otter's documentation, which is linked here. You can find all of this notebook, the slides, the demo, Jupyter Lite notebook in this GitHub repo. And then again, I have the link to that Jupyter Lite demo. And that is it. So we're happy to take any questions now.
Thank you, Christopher and Suraj. Please, a round of applause for both. We have time for questions. Before you answer the questions, please repeat for the recording. Anyone? Questions?
Hello, Nicola Thierry from Paris-Saclay. I'm currently using quite heavily nbgrader, and one of the features I like is that it works with any programming language. In particular, I'm doing C++ classes. Do you see opportunities, given how Otter-Grader is built, that it could be made to be language agnostic, like nbgrader is mostly?
Yeah, so the question was, are there opportunities to make Otter-Grader more language agnostic based on the way that it's implemented? And I will say yes. So originally, it was Python only, completely Python. And then the ability to grade R was something that I kind of hacked together one summer just because I was a little bit bored. And so there's like two main parts to Otter. There's the kind of Otter grading server, quote unquote. It's not really a server, but it's like the whole grading mechanism, and that is in Python. But it doesn't need to be in whatever language you're grading in. Then there's like a client package, and that's the part that students use to check their answers. And so as long as there's a client package available in whatever language, and that client package handles like the execution and checking test cases and like reporting results back in a uniform format, Otter can just kind of read that in. So that's what Otter does right now for R, is that the Python starts an R process, executes the student's R notebook, and the R just kind of generates this JSON that Otter reads back and reports the results from. So yes, there would be some work required to add any language to Otter, which is mainly building that client package. But yeah, it is very possible to expand beyond just Python and R.
Great question. We have time for another question.
Yeah, great topic. A great presentation. I was thinking, is there any easy way to sort of integrate this in with GitHub Classroom? Have you looked into this so that just the students submit to their directory, and then maybe just a workflow runs at some time, and out pops the grades on the other end, and the instructor does nothing except pull the grades?
Yeah. Yes, I do think it would be it's very possible to integrate with GitHub Classroom. I haven't done it yet. I did work on another autograder that was trying to do that, called PyBrite, which is something I did for Microsoft. But yeah, so Otter is just basically a Python package. It would be very easy to just have a GitHub action that pip installs it, runs, Otter has a non-containerized version of grading where you just do Otter run this thing and it gives you back our results. It would be very easy to just write. I think it would take some hacking to put together such a GitHub action workflow, but yeah, I could definitely see that being, a weekend's worth of work.
Thank you for the questions and for your great presentation, Christopher and Suraj. Please, last round of applause for our three speakers.